Please take a second and answer these before you watch the video. Let's say you've already answered them. Let's look at the limit as x approaches 0 from the left, which is what that negative tells you. So here's 0. The left side looks like this curve is going down to negative infinity. So negative infinity. 0 from the right. Find 0. The right side is up here. There's a curve going to positive infinity. So this one is positive infinity. The limit as x approaches 0 from both sides. So the left goes to negative infinity, the right goes to positive infinity, so here the limit does not exist. Find the limit as x approaches 3 from the left, find 3. The left side has a curve going up, so positive infinity. The limit as x approaches 3 from the right, find 3. The right side is this straight line, and it is going towards 0, so 0. From the right. The limit as x approaches 3 would be both the left and the right. The left goes to positive infinity, the right goes to 0, so here the limit does not exist. The limit as x approaches 2 from the right. 2 from the right side over here, it looks like it's going down towards 2.5. The limit as x approaches negative 2 from the left. Negative 2 from the left is going to positive infinity. So this is positive infinity. I think I wanted this one to be negative 2, so let's imagine it said negative 2 with a plus sign. Then that would be negative 2 here. The right side is positive infinity. And then here, limit as x approaches negative 2 left and right, because there's no plus or minus after it. And both the left goes to positive infinity and the right goes to positive infinity. So the limit is positive infinity overall. Example 12. If you plug 0 in to the x value, you're going to end up getting 0 in the denominator, which means it's an infinity of some kind, unless you can cancel the factor. So let's look at a graph of 1 over x. You should recognize this graph from pre-cal. If we look to the left of 0, it is going down to negative infinity. If we look to the right of 0, it's going up to positive infinity, and so here the limit does not exist. Or does not exist. We also could test this without a graph. If you know that you have 0 in the denominator, if you know you have 0 and you can't get rid of it, then you know it's going to be infinity of some kind. You just have to figure out which one. So what you have to do is you have to test the left and you have to test the right. And you want to pick a value. So let's pick negative 1, for example. If you plug in negative 1, which is left of 0, you get 1 over negative 1, which is negative. All I care about is whether it's positive or negative. If I look to the right, say pick 1, which is to the right of 0, you would have 1 over 1, which is positive infinity. And since these do not match, that's why it does not exist. Here we go again. If you plug in 0, you're going to have 0 in the bottom, so you know it's an infinity of some kind, but you want to figure out which one. So let's use that algebraic process I just showed you. If we plug in 0, we get 0. So we know it's going to be an infinity of some kind. So if I plug in something to the left, plug in something to the right, and see what happens. So if I plug in negative 1, I get 6 over positive 1, because when you square a negative, you get positive. So you're going to have positive infinity. Something to the right, say positive 1. If I plug in positive 1, I get 6 over 1, which is positive. Since both are positive, positive infinity is the limit, the overall limit. The limit as x approaches negative 2 of negative 4 over x plus 2. So here, again, if you plug in negative 2, you're going to get 0 in the bottom. So algebraically, if I plug in negative 2, I get 0. So it's going to be infinity of some kind. If I test -2 left, -2 right, so something to the left of -2, say -3, would be a negative on top. -3 would give me negative on bottom. Two negatives make a positive. Positive infinity on the left. -2 from the right, say -1. The -4 is negative. If I plug in -1, I'm going to get a positive. Negative divided by a positive is a negative. So these do not match. The limit does not exist. The limit as x approaches pi over 2 for secant of x. Well, remember secant is 1 divided by cosine. And think about what cosine is at pi over 2. You should know that cosine at pi over 2 is 0. So let's look at a unit circle and talk about that. So if we look at our unit circle, pi over 2 is here. So this would be an ordered pair of 0, 1. Remember, cosine is the x value of your ordered pair. And here we have secant, which is 1 over cosine. So that would be 1 over 0. So here we've got that infinity case again. We just need to figure out which one. So let's say we are to the left of pi over 2, meaning smaller, which would be quadrant 1. Everything's positive there. So it'll be positive infinity over here. If we look to the right of pi over 2, so values bigger than pi over 2, we see cosine is negative because this is the sine quadrant. So negative infinity over here. And these don't match, so the limit does not exist. You could look at a secant graph, which looks like this, and see pi over 2 is positive infinity when it's less than and negative infinity when it's greater than. So you can either use your unit circle, all students take calculus, or look at a secant graph. The last example is the limit as x approaches 0 from the right of a natural log function. You need to have your natural log function memorized. This is what it looks like. And it is crossing here at 1, in case you are wondering. And so here, 0 from the right, there's an arrow down, so it is negative infinity. The answer is negative infinity. And that is what this theorem shows you on the next slide, that you don't even have to consider the graph. You can just have this memorized as a property that if they ever ask you for the limit as x approaches 0 from the right of your natural log function, the answer will always be negative infinity.